Hello everyone. Glad to be here today. My name is Sergey Pronin. I'm the founder at the company called Solanica, and also I'm the maintainer at the project called Open Everest. What we do is we simplify running databases anywhere. It can be in the cloud, it can be on-prem, it can be in some hybrid environments. And today we have this specific conference where we talk about running databases on Amazon. And it's always interesting to me how many options you actually have to run databases on any particular cloud. And whenever you start thinking about, okay, what is it really to me running some database like Postgres in the cloud? The first thing that comes into mind is managed services, right? It can be RDS, it can be Redshift, it can be Aurora, Neptune, DynamoDB, and so on and so forth. So there are really a lot of different options. And it's the fastest way to get your database up and running. It's the fastest way for any company, and especially for startups that are seeking simplicity. They want to click a button and have their Postgres up and running with no time, without any issues. And Amazon and other clouds do it pretty nice. Uh, they let you click a button, and then you have a database that is configured with the latest version, that is secure, that has built-in a chain mechanism, that has automated backups, and so on. It also has monitoring, various different integrations within the cloud, like you can send your data from Amazon Aurora to the Redshift, for example. But it's really kind of a golden cage sometimes, especially when your businesses grow and you start to notice things that, okay, if I want to move my database out, it's not really that simple. Or my costs are pretty high now, and it's not only that I'm paying for the instance itself, I'm also paying for a lot of different other things. So there is this quick cross-check for the promise and the reality. So the first one is cost. It's always the cost, especially nowadays with a lot of uncertainty in the economy. So what clouds are telling you, hey, it's pay as you go. So you have your R5 or some kind of an instance, and you pay a fixed price, and you can easily calculate how much is that for a month, for a year, so you can plan ahead. But the reality is that there are a lot of different smaller costs, they look so, that you don't know about at the very beginning. Like it can be some networking, it can be some storage costs, it can be IOPS that when you have very performant database, you pay for IO requests. It can be for backups and a lot of different things. They just pile up, and then you're very surprised when you see your final bill in the end of the month that it can be 2x more than you were expecting. The second thing and the promise is that you don't need a DBA anymore, or you don't need an engineer. You can just click a button, your database is running, and you don't need to do anything about it at all. But the reality is you still need to. You still need to properly plan your schemas. You still need to tweak your queries. And with the inception of the cloud and a variety of different services around your database, like networking or different integrations, you might also need a cloud engineer who is going to help you to make sense for all of these things in the cloud. Um, Another promise is 99% uptime or SLA. And to be honest here, public clouds are doing a great job around the stability of their services. Um, but it works really good till it doesn't. Sometimes we see in the news that some availability zone went down or some region went down, and it's becoming kind of a norm. And it's interesting when you talk to Amazon folks and you say, hey, I have this database, it runs in this AZ, availability zone, and it went down, what Amazon is usually saying, oh, you need to configure your database to be running in multiple availability zones. We can help you with that. What they don't say is that it's going to cost you 2x or even 3x. Um, and then if you tell them, oh, you know what? I did what you said. I'm running across multiple availability zones, but my region went down. Well, guess what? They say that you need to run across multiple regions. And it makes sense. It's a good configuration, but it adds complexity, but also it quadruples your costs. And another promise is that it's just standard SQL. It's just standard MySQL. It's just standard Postgres. You can move out anytime. And that's really it. You can really move out anytime. It's the syntax of the MySQL or Postgres across different clouds does not differ a lot. But what is different is APIs, is the configuration parameters, all of these things that are around this managed service, they are different from cloud to cloud, and you need to keep it in mind when you are investing all your resources and efforts into a single cloud. What I also like when a lot of engineers they say that we use Terraform, so the reality is we're cloud agnostic. We can easily switch from one cloud to another by just changing a few lines of code. But the reality is that Terraform manages the life cycle, but not the logic of the application, not the internal pieces of the application. And yes, it is just a single line or a couple of lines of code of Terraform module that you need to change to redeploy your database in another cloud. Let's say you're running today in Amazon and then you change a few lines of code and your database is now running in Google Cloud. Yes, it's that easy. But what is not easy is to migrate this terabytes of data that you have. And Terraform can help you with this. So you are not really cloud agnostic. You're not really doing anything to avoid vendor lock, even if you're running Terraform. You are using it, but not completely. Um, so the first thing that pops into mind when you talk about running databases in Amazon is RDS. The second option is running it on EC2 instances. So it's regular virtual machines. And in Amazon, it's actually also very simple. You can just install some Linux on your EC2 instance and run some commands to have your Postgres up and running. But also what you can do is you can use some images, prepared images of some projects, and it's going to be just a couple of clicks, and you have your database up and running within a few minutes as well. And it looks super simple, right? Till it's getting more and more complex in your environment. Like you need replication, you need some backups, you need some magic around your databases, and then you create some custom scripts, then you create some playbooks in your Ansible or whatever, and it's becoming a whole team job. Now you have a team that is managing all the scripts for you, and they're extremely flexible. But in the long run, when you have lots databases and different technologies, different engines, it's becoming a nightmare to manage. And that's why a lot of folks are just saying, oh, we're going to use RDS because it's too complex to manage the databases. And yeah, uh, when you have more database engines, it's becoming uh, more complex for you. And the complexity rises in exponential level, not just uh, like when you want to add one more MySQL database. When you have just MySQL databases and then you add Postgres, then you add Redis and so on, the complexity rises really fast for you in self-managed environment. And the third piece or the third option of running databases in Amazon or in any other cloud is Kubernetes. Surprisingly, it's it was rarely mentioned a few years ago, but nowadays it's becoming a standard way if you want to stay truly cloud agnostic. So instead of running on a single cloud, what you can do is you can have your environment cloud ready. What it means is that you can be still running on premise in your own data center on your own hardware, but you can have a Kubernetes cluster that can run anywhere in any other cloud, and that makes you cloud ready. So now you can easily say, okay, if my company strategy changes, if my management decides that we're going to move our workloads from on-prem to Amazon, I can easily do it because I'm using Kubernetes and it's universal across all the clouds, all the on-prem environments and hybrid. So what Kubernetes does is that it exposes different APIs that allow you um, to use them across different environments in a similar way. For example, if you're running on-prem, there is an API in Kubernetes called Node. And on-prem, this node, it's where your workloads are running. It translates into a regular virtual machine or a bare metal server, depending on the environment that you have or the infrastructure that you have there. In Amazon, it's going to translate into EC2 instance, which is a regular compute. Also, another API example is persistent volume or persistent volume claims in Kubernetes. What it is, it exposes an API to manage different storage or to manage different stateful applications. In Amazon, it translates into classical EBS volumes. On-prem, it can be some Ceph or another block storage option like Gluster.fs and so on. Load balancer service or services or service accounts, everything like this, it translates into specific infrastructure components on Amazon or on Google Cloud. You can see that for Google Cloud, the node is going to be just the compute engine VM, or persistent volume is going to be GCE persistent disk. So Kubernetes abstracts all these underlying infrastructure components, and you can interact with them directly without any issue, without any changes when you move from one cloud to another. So for your application, for your DevOps engineers, the change is not even seen. It's completely transparent if you move your uh, infrastructure from one place to another. It's the same Kubernetes APIs, it's the same Kubernetes clusters. Um, the thing is that Kubernetes is quite complex, and complexity has been the problem number one in all the surveys across the industry about Kubernetes. So people were saying, oh, you know what, Kubernetes is complex, we love it, but it's a lot of issues to run it. And the thing is that in Kubernetes, you have all the stateful sets, persistent volume claims, config maps. And if you've never used it before, it's really hard to grasp all this all these things to understand how these things all work together. What if I don't have this thing? Should I use that on that? And so on. You need to read a lot of documentation to understand it and so on. And what makes it worse if we're talking about databases, databases make it even worse because databases multiply this complexity heavily. Not only now you have all this primitives in Kubernetes, like stateful sets and so on, but also you need to think, okay, I have all this replication topologies in my databases. I have connection poolers, point-in-time recovery. How do I connect all these concepts together in this new cloud native ecosystem? And that's actually why a lot of people are thinking that, oh, running databases on Kubernetes is a big problem. We shouldn't be doing it. And that's usually why cloud native is number three choice when you think about running databases in Amazon. And the thing is that there is a solution to that. And this solution is called Kubernetes operators that were introduced, I think, more than 7 years ago already. So the way Kubernetes operators work is that instead of learning all these components, you can install a specific piece of software in your Kubernetes environment that was developed by some well-known vendor. And then instead of creating all these Kubernetes primitives manually, configuring all these databases manually, what you do is you talk to Kubernetes in a declarative way, stating what you want to get as a result. For example, you can tell your Kubernetes API that you want a Postgres cluster with 3 nodes, with backups taken daily, with specific HA mode, and of specific version. And then what operator does is that it reads your YAML manifest that you created and thrown at the API, and then it creates all the necessary Kubernetes primitives like stateful sets, persistent volume claims, everything like that. But also on top of it, it configures the replication in the database. It makes sure that it's fine-tuned. It makes sure that backups are there, and so on and so forth. So now, instead of learning how to work with Kubernetes, how to configure the database in it, what you just do is you have some sort of specification written down of what you want to get. And it's really simple to do that. But what I really like about Kubernetes operators and what they do for databases is not just deployment, because deployment can be easy. You can write some scripts again and so on. But what operators do is that they solve the day two operations problem. So now, instead of figuring out, okay, what would happen if my one of my replica nodes go down, what do I do? Operator has it all figured out because most of the operators, they're coming with auto failover capabilities. They know that when to switch the primary, when not to do that. They know how to do point-in-time recovery and how to recover properly so that your database is not going to get stuck. They know how to scale. They know how to upgrade. So now instead of learning Kubernetes, instead of learning databases, you can just tell the operator what you want to do. An operator is just a piece of code, and there are a bunch of them. I believe there are more than a few hundreds now in the open source world that allow you to do all different sorts of things. So now you have your databases in Kubernetes cluster, which is nice. You like it. You are using your operators. And now you think, okay, I run it on-prem, I run it in Amazon. How can I easily migrate it to another cloud? Sergey said that there is no vendor lock, and there is no vendor lock. That's true, but still, the migration is not that easy. Because when you talk about the data, you still need to figure out how to move the data. APIs are the same. So you really have this custom resource definition, which is a YAML manifest describing how your database looks like. But you still need to move the data somehow. So you apply your custom resource in another Kubernetes cluster in completely different environment. Your database is going to start, but it's not going to have the data in it because all your storage is still left in another cloud. So it's not one click for now, but there are different options how to do this. So there are actually 3 migration paths. So let's say you're moving from Google Cloud to Amazon or from Amazon to Google Cloud. There are 3 options on how to do it when your databases are running in Kubernetes. The first one is PVC migration, persistent volume migration. The second one is backups and restores, is when you just do some logical dump and you restore your data. And the third one is live replication. What live replication is when you have a node, a primary node in one data center, and you stream data to another data center. But let's look a bit deeper into all of this one by one. So let's start with PVC migration. PVC migration is kind of simple. PVC is just, we remember what PVC is. PVC is just the mapping to some cloud storage, like EBS volume. So what you need to do if you do the persistent volume claim migration, you need to stop all the writes. So what you do is you just say, okay, don't write to my database. If you don't do that, then your backup is becoming obsolete because there are still some writes into the database. So you stopped all the writes, you shut down your application, nothing is writing into the database. Uh, you do the snapshot. So there are various ways how to do it. You can do it with the cloud itself. You can do it with tools like Velero and so on that are available in cloud native ecosystem. You do the snapshot, doesn't matter how, but you have the snapshot with data. Then you migrate this data. You can migrate it via S3 or some cloud transfer. The problem with EBS snapshots that you can't really take an EBS snapshot and recover it in Google Cloud because they have different formats. So usually you would use something like Velero or some other tool like that. Now you restore it to the PVC in another Kubernetes cluster. With Velero, it's a couple of clicks. And now you start your database using the same YAML manifest. It looks simple. It works. The downside here is obviously for how long your database stays offline. Because you need to stop all the writes, because otherwise there will be some stale transactions and you're going to lose some data. And I think that's the worst approach if you are migrating some production data, unless you have a luxury of having a big outage, a big maintenance window. So the second way is backups and restores. So if we use Postgres as an example, what we do is you do some kind of PG dump, or you use PG backrest or barman to take your backup and upload it somewhere. Um, then you do the restore on the new cluster. And then what you do is you make sure that you also restore your write-ahead logs or binary logs for the case of MySQL, so that in that case you ensure that you don't have any stale transactions, so you don't need to stop the database at the very beginning of this migration process. And now you need to stop your database, stop the writes, and do the flip. So when I say do the flip, it's usually you switch the traffic from your old database to the new database, because you now streamed all your write-ahead logs, your data is the latest, you stopped the database, you switched the traffic, and now you have the database up and running. But what we see mostly is happening right now in the industry is that more and more companies are relying on live replication for migrations across different clouds and across different environments. The way it works is that you have two Kubernetes clusters and you establish the replication across them for the database. So you stream your write-ahead logs, or again, binary logs or op logs from MongoDB. And that way you monitor that your replication lag is close to zero. And then at some point you say, okay, I'm going to promote uh, my new database or my new Kubernetes cluster replica to a primary. And then you switch a load balancer. It sounds pretty simple, but if I would draw the whole schema, how it works for different Kubernetes operators or for different environments, it's really complex process, and it's error prone. Even operators simplify it for you, but it's gonna work. We see it working for a lot of companies, and they really get to a zero downtime or close to zero downtime when migrating their databases from one environment to another. Why I'm telling you about the migrations, because at the very beginning, I told you that Kubernetes provides you zero vendor lock, and it's really true. You don't have to care about all the integrations between your cloud components and so on if you're running solely on Kubernetes. But at the same time, the truth is that if you want to move your data from Amazon to Google or from Google to Amazon and so on, you need to keep in mind that this migration is still not a simple switch of the load balancer of the traffic. You still need to think how to migrate the data. So great, now you settle down on Kubernetes, you are now comfortable with running all it, and now you have five operators, or now you have 10 operators. I had a customer who told me that they run 20 different Kubernetes operators in their environment for databases only. And it can be Postgres operators, Redis, Kafka, whatever. You have a lot of different operators. And the problem with it is that all these operators, they seem the same. So they follow the same logic. You throw some YAML manifest and they do some magic. But the reality is that they are all very different. They all follow different custom resources standards. They have different ways to execute day two operations. Like there are four Postgres operators out there that I know of that are production ready, and they all use different approaches to backups and restores, for example. So imagine what's going to happen across different database engines. Um, what also is going to happen when you settle down with operators, we discussed it briefly, is that operators are running on a single cluster. They don't really will work well across different Kubernetes clusters. If you need to perform migrations, if you need to do some live replication, it's always some hackish way to make it work. So there are solutions how to do that. One of them is Open Everest. It's the project that we're working on. Recently, Open Everest was accepted into CNCF as a sandbox project, but it's been out there for almost 3 years, or even more than 3 years now. There are companies and companies and businesses that are running Open Everest in production to host their production databases. And it's fully open source. So it's Apache licensed and you can find it in GitHub. What it does, it provides you a unified way to run databases in Kubernetes. So instead of working through all of these different operators, you open Everest and you click a button and you deploy databases with it. And uh, what it does for EKS, for example, Amazon EKS, is that you can quickly start with a Helm chart. You deploy it with a single command. Then it automatically configures your storage providers, like EBS volumes, your S3 buckets. You can discover them and configure them in Open Everest. And you have all the cloud native integrations that you love. So you can expose your databases with load balancers, for example. You can have different pod topologies so that your database is spread across different availability zones and so on. So running Open Everest on Amazon is a single command, and as a result, you get day one and day two operations for your databases with a single click, and you don't need to learn how to work with all these different operators. As of today, Open Everest supports three databases, MySQL, Mongo, and Postgres. But what we're doing today is we're working on a modular architecture. We're doing it in full transparency. We have all the specs. We have community meetings where we discuss it. The plan is to roll it out this month as an alpha version. And what we would be able to do is that we would be able to add any database engine into Open Everest easily. So instead of just having three database engines, we can have 20. And that would be a matter of days, not months of engineering, because all our databases in Open Everest are going to be treated as plugins. And then we also expect that community is going to jump in and work on these plugins with us and expand the capabilities and the value that Open Everest provides. Another thing that we're working on right now in Open Everest is multi-cluster deployments. Is that what I was talking about when I was talking about migrations? That operators, they actually work within a single Kubernetes cluster. And that's why migrating from one KH to another KH for databases is quite a process. But what we want to do in Open Everest is to simplify that. We want Open Everest to be an orchestrator of operators and databases across different environments so that now you don't need to think how to avoid this vendor lock in one cloud or how avoid this complexity when you run on-prem but you want to be cloud ready. It's going to be extremely simple for you. And the third thing is, yes, is we're working on migrations, like not only across different Kubernetes clusters, but also how can I move my data from RDS to Open Everest easily without all this magic with backups and restores and downtime. So we want to introduce plugins that are going to ease this migration processes and to simplify that a lot. We're building in the open. We have our vision on vision.openeverest.io. Open Everest comes with a nice web UI, with APIs, with the CLI tool that you can use to run your databases at scale. So Open Everest is deployed in the open. We are simplifying the way databases are running on Kubernetes and as a result on any other environment. But what I want you to get out from this talk is that there are different options of how you can approach running databases in the clouds. One of them is RDS, another one is DUI. But if you want to be not just running in the cloud, but be cloud ready and be able to migrate from one cloud to another, then I think the best approach here is to use cloud native ecosystem and cloud native technologies. You can start with operators, or you can jump in and start using Open Everest, because with Open Everest, the future is bright, and we expect that you would be able to manage your databases with this across different clouds and migrate them easily. So you don't need to really think about how to avoid the lock-in, how to simplify the complexities that Kubernetes and databases bring to your engineers. That's all from me. Thank you all for joining. There are some links here where you can find us on GitHub and Slack and so on. The easiest way is go to openeverest.io. Thank you. Have a great day.